Okay. Good afternoon, everybody. How's everybody? How's everyone? This all good? This cold day? All warm? Okay. Okay. So our week 6. Week 6, what is it that we have to do here? I have a few things to cover. We're gonna start by finishing inheritance, okay? So we're gonna wrap things up in terms of inheritance. Then we're gonna jump to some exercise about that. In our second hour, we're gonna start with polymorphism. Very complicated word. Hopefully the topic is not that complicated. So we're gonna start polymorphisms here. We're gonna take a break. We're gonna do our quiz 3. Should be around 7 p.m. Okay, so I don't want to leave it as the very last thing. I want to do it a little bit earlier. And then, to wrap things up for the day, we're gonna finish by talking about abstract classes and interfaces. A very light conversation at the very end of the class. Very light one. Just abstractions, interfaces. Okay, so I'd like to start by reconnecting a little bit with where we left off last class, okay? So I don't expect you to remember anything from last class. Well, not anything, something. But I want to reconnect with a few of the things that we have discussed last time. I'll be sitting down more than what I normally do because this table is not coming up. So for me to keep doing like this, for some reason this is not coming up. Anyway, so we stopped last time just around talking about base, about virtual overrides, new overrides. It was around that we stopped last time. Kind of confusing topic. We had this virtual in the parents. Anyone remembers what virtual in the parents means? If we have, yeah, so if we have virtual, the virtual keyword in the parents method or in the parents properties, it means that, hey, the children can safely override them. It's almost like an invitation for the children to override those methods, okay? Now, the children also has the option to say, hey, I don't want to override, I just want to redefine that. I want to use the keyword new. It's possible. As I mentioned last time, I'm not going to hammer too much on the small nitty-gritty details about the difference between virtual and new and virtual overrides. There is a minor difference, but I'm not going to be asking you for that. Description-wise, you can use this as a reference point, but again, new is like the children saying, I don't care what you did up there, I'm going to do my own thing here. Override is that, okay, I get it. You are authorizing me to redefine you. I still want to keep the link between us, so I'm going to just override it. So I'm just trying to easily translate what they mean. Yes?
Are they by default virtual? Or?
There is no by default. Well, you can say that if you don't use the keywords, look, if you use no keywords in the parent and no keyword in the child, in a way, you are doing this. You are using this option here. It's the same as using virtual and new. So you can say that the default behavior, if you don't put any keywords, will be this one here. Okay, does that answer? Okay, yep.
They change in the child, but also change in parents, or?
Actually, override is the one that does this kind of thing. Is that it's not that it changes in the parent, it only changes in the child, but with virtual and overrides, the reference between the child and the parent for that method is still kept. But when you say virtual new, new really means that the child is redefining that method completely. It's not even caring about overriding it. Yes, that's correct. That's correct. But again, the differences are a little bit too subtle. I really don't want to hammer too much on that because we have so much more important topics that are not that easy to cover here. So again, I want to keep moving forward. There will be some topics still around this that I want to focus a little bit more, okay? But I would like, let me see here. Yeah, so I would like to continue now by talking about implicit reference conversion. Very, not complicated, but again, a big name for something not so comprehensive, not so, for something a little bit minor, I would say. Implicit means that it's doing something that it's automatically doing something for us, okay? So that's the implicit part. Reference here is just because we are using objects in classes, and when we use objects in classes, we are using reference types, not value types. In conversion, we are converting from one thing to something else. Now, in this case, we are converting from a child to a parent. And I'm going to show you an example of that, and let's see. Okay, so the example the demonstration, the example that we have worked last time, it was this one here with employee as the parent and commission employee as the child. Here in this rewritten example, I broke them down into different files, and then we have the program which is using them. So it's declaring an employee, declaring a commission employee. Now, let's look here. Let's look at this. On employee, we have getGreeting. GetGreeting is a simple method that returns a string, okay? Hello, I'm employee number 10. We have a similar one, getGreeting, for the commission employee, which returns, hello, I'm commission employee number so-and-so. That's it. So a minor difference here. But again, they are behaving slightly different. The point is that if we go to program, in our program application, program class, we have created this method called displayGreeting, which will read the greeting message from the parent employee and from the child commission employee. Now, look at this. We just have employee as the type of the parameter, okay? Just employee there. Well, but what happens, I mean, salesperson is a commission employee. Salesperson is not an employee. So, should this give an error, a compilation error? Because I'm sending a different type here. How come there's no error there? If I was sending, an integer, here, I'll get a compilation error. But why is that I'm sending a commission employee? See salesperson here? Why can I send a commission employee to this as this parameter here in this method? What's up?
Because it's the type of an employee.
Well, the type is commission employee.
No, but commission employee is an employee as well.
Good, that's correct. Because commission employee is also an employee. So what I'm trying to say is that you can send any type of employee as this parameter there. We could have a contract employee, a temporary employee. As long as they share the same parent, employee, they can be sent in that slot. Any one of them can be sent in that slot, okay? So what is happening here is a an implicit conversion from the child's commissioned employee to the parent's employee. Okay? From the child's to the parents. So that is an implicit reference conversion. We are converting implicitly because there is nothing here under this line that says that convert this salesperson to, this commission employee to employee. There is nothing there. It's doing that automatically, implicitly for us. Okay? Now, you may say, why do I care about that? What does that mean? Well, here's what does that mean. With one single method, now I'm able to access properties methods from both types, from both commission employee and the parent employee. I can use the same method. To this method, I can send employees, I can send commission employees. The method will behave the same way, and it will be compatible with both of them. So all of a sudden, I can work with either employees, commission employees, or any other types of employees, all at once from one single method. I don't need to have a method specific for each one of them. I can use just the employee being an employee or commission employee, or even if there is a third child there that is a child of commission employee. Doesn't matter, but what matters is that in the hierarchical tree, they are all at the end employees. Okay? So that's the implicit conversion here. We're going to see a few more examples of that applied to different scenarios, applied inside loops. Anything?
So, you said that the most basic class was object.
Yeah.
So, could you use object as a
We could.
parameter in there?
Actually, let's give this a try. There's a problem there with object though, but let's give it a try. Look, again, let's follow the logic here. As I said before, object is the parent of all classes. So I could say something like this, object. However, there's a problem there. And who tells me the problem? I mean, why is complaining about that?
Not all objects have data.
Because object does not implement that guy. So inside this method, I can only use properties methods that are common to all of them. So it has to be available to the top parents that we are using here. If we go back to employee here, look, commission employee has commission rates. It's a property that is not available under employee. So here, I cannot say emp.commission rate because commission rate is not available to the parents, just to the children. Okay? So I can only access here whatever is available in the topmost parents. Okay? Good question. Okay, and actually that's a good segue for what I was going to talk about next. Let's see here, which I'll be talking about objects. So again, this is implicit reference conversion. A lot of blah, blah, blah there that you can read on your own. Example here, that's the example that we were talking about. New and override, I covered this already. So again, as a segue to objects. Object, as mentioned a few times, is the parent of all classes. All classes, in the very end, they inherit from objects. In a way to prove that, let's have a look at this example again. Look, we have employee here. If we have a look at employee, employee has one property called ID number, one method called get greeting. So I would assume that if I say clerk, which is an employee. And if I say clerk dot, I should be able to see what? ID and get greeting, correct? Just those two, because it's the only thing that is being displayed here. However, look at how amazing this is. Dots, we see ID number, we see get greeting, but we see some other stuff there. Where are this other stuff coming from? From where? From employee doesn't have them. From object, because in the end, although it does not say explicitly here that employee inherits from object, but it does. It does. This would be the same, and I don't even know if it works like that, but this would be the same to do something like this. They all inherit at the very end, even if we don't mention that, but they inherit automatically from objects, okay? So those other properties, they come from object, like toString, getType, getHashcodes, equals. We're going to explore a little bit further toString, okay? We're going to be overriding toString. Actually, before we try that, let me show you something. It's something very useful here on Visual Studio, that you can jump from one piece of code to another one quite quickly. So if I say object O, look, if I want to get the details of this class, I can right-click, and I can go to definition. I can do that with any classes. Look here. This is showing me what are the different properties and methods of, actually we just have here what? We just have methods here. Of object. Look at toString. toString is flagged as virtual. What does that mean? That we can override that. We can override that behavior, okay? So it's a way that object is saying, I'm inviting you to override if you want, okay? Before we try to override that, let's see what happens when we call toString from any object. Let's see what type of string we get there, okay? By default. Okay, so I'm going to get rid of this part here. Let's try this. Let's try clerk dot toString. And let's try salesperson dot toString as well. Let's write this out to the console. And I'm just going to comment this out here so we don't display this. We only focus on whatever is being output by toString. So I'm going to run this. Okay, just going to quickly select that. I'm going to paste in a text editor so I can increase. So here's what we get out of toString by default, okay? So by default, what is this? What is this first part before the dot? The namespace. So look at this. So we have the namespace, and then dot, the name of the class, okay? So that's the default behavior of toString. Oh, Ederson, what am I going to do with that? I don't know. I don't know. If you need that, you have that, okay? You can get the string of the name of the type, the string name of the type. Again, you can use this maybe to test the type. Maybe if you have a situation that you need to test, if it's a cat or if it's a dog, well, hopefully you don't need that because you're going to be working today with magic polymorphism. So you don't need to do ifs and else statements. But this is the behavior of toString by default. However, we can say, you know what? I don't want that. I want to redefine how how toString works, okay? So we can redefine because toString is virtual and we can override toString. So let's do that. Let's do that with employee first, okay? So let's do this public. I'm going to use the keyword override, okay, because it's virtual there. I'm going to override here. Override. It returns a string, so I'm going to say string, toString. Again, pay attention to the capitalization. You're going to be using toString in exercises, most likely in the test as well. I'm going to ask you to override toString. Again, it provides you a quick and simple way to output some data from all the different fields and properties of that object if you want. So I'm going to do this. Sorry. And I'm going to say return. For now, I'm going to return nothing. So if we run this, toString here won't show anything. See there? No string there. Awesome. But I don't want that. I want to make this a little bit more descriptive. Maybe, again, this is an easy way. If you override toString, it's an easy way for you to collect all the properties from all the different fields in the class and output them all at once by just calling toString. You can say something like this. Employee number, I can say. Again, if we had more properties, we could list them out here. We could, if we had 5 more properties, we could put all of them here, and then we could call toString, and it would show us right away all properties from that class, okay? From the object. Now, because commission employee inherits from employee, when I run this, I'm going to get the same thing for both of them. Okay, so I get employee number for both of them. Of course, each one has a different number, but the message is the same. Got it? Now, can I override this again, but now in the commission employee? Yes, you can. Okay, so I can do this. Even though I have used override here already, I can use this again in the child. I can keep using this continuously. I can say override again. But now I am a commission employee. So I change the behavior, and if I run this again, I'll see the 2 different messages there, okay? So again, virtual overrides, virtual is an invitation to override, but it's not mandatory. We're gonna have a look at certain things today that will be mandatory, but not as far as this goes right now. Questions? The numbers? Okay. So the numbers are coming from the ID number property. So it's reading the ID number, and it's outputting here. Okay. Oh, how they came about? I hard-coded them. Look, hard-coded them. Okay? Yep.
So, stop me if this is something that you're planning on talking about.
Okay.
But, in f.getGreeting,
Yep.
because the parameter is of type employee, does it still use getGreeting from commission?
Only if the object that is being sent is a commission employee. So it no longer becomes about how it's declared here. It becomes about what you send in. So if you send in the child, it will call the child's. Now, you know what? This is the difference between new and overrides. It is. Because if you put new, yes, that's what I mean by a subtle difference. Because if you send, just that, if If you use override and new, and you send a commissioned employee here, it will call the method of the parent, not the child. If you use overrides, if you use virtual and new, it will always call the method of the parent. If you use virtual and override, it will call the method of the parent. If you are given a parent object, it will call the method of the child if you are sending the child object. Again, I don't want you to get hooked up on that, but it's good that that came out of my system. Now you know. Now you know the secrets.
In this case, it's calling from the parents. In this case, right now here, like
it calls from the parents right now. It calls from the parents if you send an employee, but it will call from the child if you send a commissioned employee.
In this case, you put console right lines for both, right?
Yes.
Because you put the employee, but if you want to put like the child, you can put the child too, right? You can put the...
Are you talking about the method here or this thing here?
Inside of the parameters that you have the employee.
Yep.
Like can change, for example, for like a commission employee.
If you change for a commission employee,
It's going to be just for the child.
just for a child, the parent, you won't be able to send the parents. But if, as it is right now, if we put there the parents, we can send the parents or the child.
And those things in the parameter must have like the same thing as like overloading, like a string and string must be exactly the same, or inside can be anything.
What do you mean by inside?
Inside the parameter.
Inside the parameter or
No, inside in this method.
inside the method?
Because they don't have no, in this case, because you don't declare like it's not a variable, right?
Yeah, it's a parameter.
The parameter is not like a data type, not like a variable, not a
Well,
string.
it's a class.
It's a class.
It's a class, but the class has properties which can be strings, can be integers, can be numbers, can be primitives, can be.
In this case, you got everything. You have like a multiple choice.
Multiple choice in the sense of parent and child?
Parent and child.
Yes. Okay? Okay, so let's see here what I'm trying to get to. Yep. Okay, so we spoke about objects. Let's see here. Okay, so we did this overwriting here. Okay, so we're gonna wrap this up with constructors. But let me hear from you first. So again, tell me, any questions about inheritance so far? Again, we're gonna have a moment in our second hour to do some exercises. And again, with exercise, usually things get a little bit more clear, or maybe not. But if it's not more clear, I'll be around to assist. But questions? Okay, so let's wrap things up with constructors. So we have seen constructors before already. We have seen overloading constructors with different number of parameters. What are the two aspects or characteristics of constructors as compared to methods?
Same class name.
Same as the name as the class and no return type. Yep, awesome. So constructors here, they work the same way when you are doing inheritance. But there are quite a few things that we need to be mindful about. Okay? When we are dealing with constructors, the child constructor will call the parent constructor automatically. Sometimes maybe we have to call them. But the point is that there is a cascade effect when you create a child. When you call the constructor of a child, that constructor will call the parent's constructor automatically. And we're going to see a few of the different nuances, let's put it this way, about that. Let's start by having a look at this video from Joyce.
This is Joyce Farrell.
Oops,
Let's look at constructors and the role they play in inheritance.
Too much.
Suppose you work for a company that manufactures sunglasses, and so you decide to create a sunglasses class. Assume that two of the properties
You start again there.
constructors and the role they play in inheritance. Suppose you work for a company that manufactures sunglasses, and so you decide to create a sunglasses class. Assume that two of the properties that sunglasses have are a frame color and a lens color. Also assume you have a constructor that takes no parameters, but that sets the frame color to black and sets the lens color to brown by default. Now assume you create a child class of sunglasses called prescription sunglasses. It inherits from sunglasses. That means that every prescription sunglasses object will have a frame color, a lens color, and assume it also has a diopter. A diopter is simply a number that represents one of the values as to how strong a prescription is in a pair of prescription glasses. Assume the constructor for this child class is also parameterless, but that it sets the diopter to 0. When you declare an object of type prescription sunglasses, you call the prescription sunglasses constructor. It in turn calls the sunglasses constructor, which executes first. So when you declare a pair of prescription sunglasses, you get black frames, brown lenses, and a diopter of 0.0. The black frames come from the parent constructor, the brown lenses also come from the parent constructor, and the 0.0 diopter value comes from the child constructor. Assume you have a different sunglasses class that has a non-default constructor. This one requires a string representing the color that is then sent to frame color, and another string for lens, which is then sent to lens color. Now when you create a child class, because the child class constructor is going to call the parent class constructor, you have to have two arguments to send to the parent class constructor. In this case, we're sending two strings, red and yellow. Red will go to the parent class constructor and become color, and yellow will also go to the parent class constructor and become lens. Diopter will still be set in the child class constructor. So now when you declare a pair of prescription sunglasses, you get a red frame, a yellow lens, and a diopter of 0.0. Here's a different way the prescription sunglasses class might require 3 parameters of its own: color, lens, and diopter. 2 of these could then be passed to the base class constructor, color and lens. Color could go to the base class color parameter and lens to the base class lens parameter. Then the diopter could be set in its own constructor. So when you declare a pair of prescription sunglasses and use the arguments purple, pink, and 3.0, you get a pair of sunglasses with purple frames, pink lenses, and a 3.0 diopter. Thanks for watching.
Okay, so let me step back here and let me review all 3 examples, okay? So the first one, this was the situation there. Both child and parents, they have constructors that are called what? Constructors without parameters. They are called defaults, default constructors, okay? So we have the same, no parameter, no parameter. Now, when we have default constructors, the default constructor will call automatically the parent's default constructor. So we don't need to specify we don't need to call explicitly the parent's constructor. It's called automatically for us, okay? Again, if you create a prescription sunglass, it will call this constructor, and then it will call this, the second constructor, okay? So the first one from the parents, the second one from the child. However, when you have constructors that require parameters, you have to explicitly, actually let me rephrase that. If the parent class does not have a default constructor, a constructor without parameter, then the child has to explicitly call the keyword base. Keyword base means the parents, okay? So it has to explicitly call the constructor of the parents. If we don't do that, it won't compile. If we don't put this here, it will assume that it's trying to load to call the default constructor, but in the parent has no default constructor. It has one constructor with 2 arguments. Now, if this parent here had another constructor that had no parameters, yes, we wouldn't have to put this here unless we want to really call this constructor. But again, we have to call base with the correct number of arguments if the parent does not have a default constructor. This is a very good point for a quiz. So if you want to write a note about that, I would invite you to do that. Okay? And usually when I say that it's a very good one to be in a quiz, it will be in a quiz. Okay, so I'm going to say again, but you can always check the recording. So if the parent does not have a default constructor, the child has to call a constructor with arguments. Yes.
What if the parent's constructor have the default and the child I want to define another colors?
That's fine. So if it has a default already, if the parent has 2 constructors, one is the default, one is with parameters. In the child, if you create a constructor that has no parameters, that doesn't call the parent constructor explicitly, it calls the default one. So again, if you don't put base there, it's going to be calling the default constructor. But you have the option to put base and call the other constructor.
It's going to override the parent's...
There's no overriding here. We're just directly calling them. There's no overriding because, remember, when we're dealing with overriding, we're dealing with things that have the same name. Here, this constructor is called prescription sunglasses. This one here is called sunglasses. So there's no overriding relationship here.
My question is if there is colors in the parent constructor.
Yeah.
But in the child constructor, I want to change the colors.
Okay, so you can. So do whatever you want to do here in the parents, and then the child, because it will be the last one to run, so it doesn't matter what the parent will do, the child can always undo that. You got the idea? Because again, first it runs the parent constructor, then it runs the child. So whatever the child says, it's the final word in a way.
So if the parents, in this case, the parents constructor, you were saying that with black and with brown, the length was brown. But when you call in the child, they just like a replace, right? They are going to show the last thing that is going to show is from the child, right?
Yeah, the last code that runs is this one here inside.
The one inside.
Yes.
But in this case, you can use this when in the parents constructor they don't say nothing. When they just
Guys, if you'll be talking, hello, excuse me, in the corner, if you're going to be talking and using the class, I mean, come on, you have to move to another class, or you keep quiet. Sorry.
So,
Say it again.
when in the parents, they just declare, when they don't put any colors.
The parent doesn't put any colors. Okay, okay.
So the child must declare in this case, right? The parents, the child constructor, they must put this base and red and yellow, right?
If the parent doesn't have parameters,
Yeah, doesn't have parameters.
then there's no base to call. I mean, remember at this base, I'm calling the constructor that is created in the parents. So if this constructor here had no parameters, there's no base with 2 parameters then.
Not parameters, they have values.
Values, you mean inside the code?
Yeah, inside.
Okay, okay, got it. So, okay, so it's assigned some code here. Here I could assign to something else if I wanted. because it will run first the top one, then the bottom one. Whatever the bottom one does, it's going to be the last one, yes, the last one, okay? So that's the second example there. Let's go to the, yep.
I'm just curious, so if there's a class from the inherits another class, and there's another class inheriting from the middle class. So if I need to call, call the constructor from the grandchild class,
Yep.
then I understand that we need to go to the middle class and then the parent class. But can we just go like all the way up and just call the first
Just
class?
go straight to the,
Is there any way from there?
no, no. So actually, let me ask this question. When, because it's pertinent, it's related to what you are asking, when you create a new prescription sunglass, how many constructors get called? Sunglasses. Oh, sorry, prescription sunglasses. How many? How many constructors get called? 2, 3, 4, 5? 2, why 2?
Child class and the parent class?
Okay, any other opinions out there? So, with that, 3, why? Yes, from the object as well. So, this one here, the constructor from sunglass, this guy here is calling the constructor of its parent as well. Who's the parent? Object. So, even though there's no definition here of base, but it's because it's calling the default constructor of the object. Okay? We may not see it, but it's there. Okay. So let's move forward here to the last example. So in the last one, we have now the child has parameters as well, the constructor. So we have 3 parameters there. So now here's what I can do. I can map parameters in the child's constructor back to the parent's constructor. I can say, okay, you are in the child, you are receiving color. Get that color and send to the parent. So I can say color here. This color name here, it's coming from this parameter here. It has to match the same name, okay? Oh, and lens, you need lens as well? Yes, I need. Okay, so lens, I'm sending you lens here to the prescription sunglass. Send this back to the parents too. So I can map them out, and I can send them out to the parents. And then I can use the third one inside the child. Because again, diopter, there's no diopter here. Just the child, okay? Again, a lot of little details, I get it. As you do exercise, as you practice this becomes a little bit more clear. But again, make your notes there. Next week, the tests will be up to here, or down to here, to abstract and interface. We're gonna be talking about that in a little bit. Actually, yeah, in a while. So constructors. Again, questions. Question about constructors. Here we have an example. Let's have a look at an example here. Our commission employee. Yeah, let's see that. Okay, let's see, where is that? Let's see if I can. Okay. I think that we can use this as an example. Yes, we can. Look, I'm going to... Let me do this for now. Look, I have an employee class. It has a constructor without parameters. I have a commission employee. It has another constructor without parameters. But again, each one of them, it's doing something. Let's see, this will prove which one is running first. Because in our main, we are creating a new commission employee. So look at this. According to our theory is that the parent's constructor runs first and then the child one. So if I run this, employee constructor that gets called, and then commission employee constructor gets called after that. So it shows that first it goes to the parent and then to the child. Okay? Okay, what else we have here? And again, to call arguments to call the parents, we use the keyword base, as this example here. Okay, again, any questions? In the next hour, we're going to be doing some exercise. Let's take 5 minutes, let's have a break, and we will come back, we jump to the exercise, okay? 5 minutes.
So what is the question?
Maybe I missed it, but did you talk about, like, if the child takes in parameters that then is going to set to the parent's constructor?
Yeah, that was the last example, that the child was getting color and lens, and then it was being mapped to the base. So whenever we call the base, inside the base parameters, we put, if the name of the argument is called, the parameter is called color, we put color there. Lens, we put lens there.
Inside the constructor of the child, you would...
The body?
Yeah, in the body,
Yeah.
you would put base parentheses.
Not inside the body. It's actually right in the header, you put column.
Oh, right in the header?
Right in the header.
You still use the parameter?
Yes. Right in the header, you put, before you start the open curly braces, right in the header, you put column, and then base, and then you send the arguments there to the parents.
You can just use the arguments right there.
Yes, right there. Okay.
So this one belongs from the second. As for the inputs, yeah, as for the user. As for the user. Here's the second, and here's the first plugin, right? Is this one. It is all the information.
Excuse my pseudocode.
Okay, no
Like-
problem.
Okay, so let's say that you had a grandparent.
Yep.
Because constructor that accepts a string for color.
Got it?
And then the parent
Yep.
doesn't accept any parameters in it, and it puts in blue as the color.
Okay, that's fine.
Can the child then somehow assign a color to the grandparent? Or
Okay.
because it's getting overwritten by the parent.
So, okay, yeah. So here's the thing. Let me ask you this: why do you want to assign this value all the way up? Because because here's the thing: the way it is right now, you cannot.
Okay.
But you can always put this value right here in the property.
Just assign. Like,
Just assign it here.
Like, yeah, so you do your
Like
base and base and-
Not even base. Forget about the base.
Okay.
Because let's say that there's a property called color in the parents.
Oh, yeah.
That property is visible to any one of them.
Right.
So you can just at the very end say color or this dot color
This stuff color. Okay.
equals to this color here.
Okay.
Okay?
Okay. All right. Thanks.
No problem. Okay, so I have a small little quiz for us to, not graded, okay, so no worries about that. But it's a slightly different type of quiz. We're gonna have a race. Are you ready to race? We're gonna have a race to the mountain. So let's put this code. This is about speed, it's about accuracy, okay? We have 5 questions. Each question will move forwards automatically after 30 seconds. So you're gonna have 30 seconds, but I suggest that you go fast because, again, you are competing. I'm serious. And you're gonna be using the Valentine's Day theme in honor of this cold day. Let's randomize the answers. And I'm gonna hit continue. And you're gonna start, here's the code. So again, let me know if you need to see it better. Okay, sorry, the codes disappeared here. Let's see, yeah, so here's the code. Not yet, nothing for now, nothing for now. First log in, first put your ID there. Now let me see here how many we have. Okay, come on, we have more than 11 people here. So X, B, S,
Yeah, nobody's a truth.
okay, so we have, I think, everybody. Okay, so I'll give, so there's 19 people, 18 are there, that's fine. You're gonna start like that, okay? So again, 30 seconds per question, 5 questions. It moves automatically. Okay, I'm gonna show the names.
Yeah, that's so big running.
Okay, who's CDB? CDB? Good job, CDB. Mike, keep going there. Jim, good job, Jim. Come on, CDB. Come on, Igor. Let's hide this. Oh, you can see it. You can see it. Ooh, let's see what we have there. Come on, Igor. You can do it. And the last one. And ta-da-dan, ta-da-dan, tan-tan. Awesome. Okay. We have CDB. CDB will review yourself, Igor, and 01. Again, Igor, I know. CDB. Woohoo! Congratulations. Come on, everybody. Thank you for the 3 winners there. Awesome, awesome. You can use that in your e-portfolio, okay? So you can take a screenshot, put in your e-portfolio, okay? Okay. Great. So let me take the annoying music there. Okay, so now what we're going to do is this. We're going to go to eCentennial. And we're going to go to week 5. This topic is the wrap-up of week 5. So on week 5, you may have done this exercise already. I don't know. I mean, who has done the exercise on week 5 already? Not too many people. Okay, so now we're going to have a chance to do those exercises. Again, it's up to you to decide which one you're going to be focused on. You can do it 1, 2, 3, or you can do programming exercise 5. All the solutions are already provided here. You do it solution, you program exercise 5 solutions. Also, you have the video solutions for all of them here as well on the top. Again, the idea is that practice what we have gone through. Do the exercise that you want. I'll be walking around. I'll be assisting the ones that are stuck with anything. But for the next, for our next segment here, up to our intermission, we're going to be doing this exercise, okay? Those exercises. Again, I'll be walking around, helping if you need help. Use this time well, because this type of exercise, this is what we're going to be doing next week during our midterm, okay? Okay, I'm gonna take a quick attendance here, Andrea. Anjali, Chloe, David, Dharmik, Dinesh, Igor, Elgin, Eric, George, Hao, Hong Viet, Jayanth, Jessica, Karanvir, Kenneth, Krupam Ben, Michael, Naserj, Osman, Philip, Rafsan, Raul, Rafael, Robert, Siran, Siranjit, Sona, Thimin, Walid, Zian. If I did not call your name, let me know. If anyone wants to use this time as well to do any wrap up on your assignment, too, you can as well, okay? So just let you know. I'll go from behind. Let's see if that works. Can I see it from here? Becomes easier. Date. Well, for this example, you can use a string, but you can also use a date time. If you need a date time, again, the type is called date time.
Yeah, I did that date time.
Yeah. How do you set that? Put between dollars number sign. Put a number sign there. Let me see if that's. I think it is number sign. The number, the tag hashtag. Yeah, and then finish with that as well. Let me see if that's. I don't think it is. Click outside. Yeah, I don't think it is. Okay, so try this. But date time, you can say equals to new. Sorry, in that same line that you set the number there,
Oh, got it, okay.
equals to, yeah, get rid of that, equals to date time, new date time. Yep, new, yep. And then you have parameters there. This constructor accepts year. No, you don't put like that. Actually, open the, look. If you just put it like this, see, you're gonna have different arguments. Look how many constructors we have here. So you can put the year as a number, the month as a number, the day as a number. But comma, you put commas there. Okay? And then it will create that for you.
Question. So how do we use get type?
Get type, I won't explore too much that. It just returns the type of that class. You can just say get type. You can just call it just like that, and concatenate with the rest. It returns the class, the name of the class. Yes. Okay.
So in the latter class,
Mm-hmm.
so we implemented the two properties,
Yep.
name of date,
Mm-hmm.
and
Got it.
to override this because this is also in built
Yep.
method. And in this we inherit
Tracking
the
number.
latter
Yep.
class,
Mm-hmm.
tracking number. So in this we have to create object for this certified letter.
Yeah, does the exercise ask for you to demonstrate anything? Again, if the exercise is not asking you anything specific, you can create one object from each one and just demonstrate the use of some of the
Display
properties.
the
Yeah, display.
properties in it.
Yep.
Okay, and set the properties and display the
Yep.
values.
Mm-hmm.
Okay.
Okay.
say 8" by 10", you mean width by height, right?
Yeah, width by height.
I have a question about assignment 2.
Yeah.
We made 2 versions and we want to see which one is this is the first one.
Mm-hmm.
So when I enter the first name, how much do you give for this one?
How much what?
For this one.
I have no idea. I didn't review the codes. I do think it's just about that. I have to review the codes.
Okay, I'm gonna show you the second one. This one, yeah. No, I didn't change it here.
Did you validate if you put values outside of the range?
Yes,
Yep.
yes, yeah. We put a try pass.
It should be positive and it should be between 0.1.
Yeah.
Yeah, so if it's
those are-
not, what happens?
It gives me an error or message and it asks me again to.
Yeah.
So
yeah.
it will ask until you get
Yeah.
something.
That's
Okay.
Yes, between 0, 1 or 1.
Okay. Okay, that's good.
We will try pass.
With the try person.
Okay.
Use the try person.
Well, try parse, it
To
will,
not crash. You do some
it will, if you put a string, yes,
Yeah,
it
yeah.
avoids that, but it doesn't avoid the range.
Ah, yeah,
No,
but
no.
we put the-
Okay.
Doing while.
Okay, okay, okay.
Yes.
So first it should show the default or.
That's fine. I mean, if the exercise is not specific about that, you can show the first one, and then you can collect information for the second one. Again, I'm not gonna take points if you show something first or whatever. I mean, as long as you are following what the exercise is asking. What's the question? Any specific question?
Because I have two versions, so
Okay.
we are arguing which one is better.
Well, you should argue. Don't include me on that argument there.
No, I guess it's more about interpretation because they were saying that we must put default all the values, right?
Not default all the. There are 2 or 3 defaults there. 0.1 is the default of something. 1,000 is default from another thing. So
Yeah, but
You
for
have the
example,
file, yes.
Yeah, because it asks for put the false values in
constructor.
and we put these defaults in the constructor because there are 2 constructors. One the
Yeah.
default constructor that don't receive any parameters. Here we
You have
initialize all the
assignment.
files.
All the
And
the fields. Okay. Yep.
with the one that says with this value, this value, this value.
Yep.
And for the other,
Yeah,
we
that's
assign
true.
any other value that we should.
That's okay.
And for the second constructor, we put we ask the user to
To enter the information. Okay.
the information.
Oh, no, yes.
Yep.
No, because you say about the 2 overload constructor, right?
Yeah. So one without parameter,
Yes.
and the other one with 3
But
parameters.
in one of them put instantiate all.
All data
yeah.
members, all
Yeah,
fields,
all fields over there, right?
Yep.
Yes. And in the end, we are demonstrating like for one constructor and
And
for
the other
other
one.
constructor.
Yep.
Okay.
You can debate. I'm gonna leave you to debate. Yeah.
In the exercise, in the that say do it,
doesn't
in
show.
the number 2, it does.
It doesn't show that.
It told us that we need, because it's first of all, the loan amount, it is auto properties.
Okay.
We need to create a file.
Okay.
That is loan amount. Because I need to put this one inside of the set.
Yep.
However, he told us that we need to call it as protected. But I also can leave it as private,
This
and
one,
I
okay, it gives me all
even
the.
have this
What
property
about the second
duplicate.
one?
That's okay. Protected is only if you need to access from the child.
But if I leave as private and I access from the child with the property, it's okay.
Here, right? That we want for
Because
the first
it's
for the
public, the
second
property
object.
from the child, I can also access for the property.
That's fine. That's fine. As long as it works according to what is being asked there. To be quite honest, I don't remember the details of each exercise. So again, as long as it's doing what the exercise is asking,
For the second, it should ask.
you're fine.
Yeah, that we have.
Okay.
Now we are asking for the first.
No, this is
For
the second.
example, when you create
This is the
a
second,
protected
the second
and
one.
public, and when you need to create private
So why
and
don't we
public,
show this one here?
So okay, so here's the thing. If you make this private, you know that already. Can only access this field inside this class, not from the child. If you make it protected, you can access the child. Now, you are saying that, okay, I don't need to access that because I can access from this one here. But what if you want to access it? You may see the set it has some rules here. You see those rules? What if you don't want the child to apply those rules? What if you want to access this low amount directly? You may want to access directly without, but you may want directly bypassing this whole thing. You may want that. So that's when you want to access that one. It's when you want to bypass all those rules there. If the child wants to bypass that, with protected you can, with private you cannot. Okay? No problem.
Also, the object, you told us
The
that
what?
the object,
Object?
is the parent of all classes.
Well, so let's put it this way. The object is the topmost ancestor. Now, if I have an employee and commission employee, who's the direct parent of commission employee? It's employee. But if we keep going up, 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 we're going to reach objects. So who's the parent of employee? It's the object.
This object is the same for all the classes.
Yes.
that I'm going to create.
Yeah, it's one class called objects. It's not any object, it's a class called objects. Okay?
No, yeah, just do it like a with
You sent some questions about the assignment, was it? Was you? Yeah. Any more questions about that? I mean, anything else?
Not sure.
Uh,
One of my groupmates has the final work, so.
Okay, okay, that's fine, that's fine. I'm just checking.
One we're missing. I don't know what we're missing.
Okay, that's fine.
Maybe we can show it to you after class.
To show the assignment? Well, this is the time to show the assignment. This is the time that we have exercise. Why wait for after class?
I'm gonna get the files.
I have a question.
Yes.
So I'm doing this one,
Mm-hmm.
and it says set it to and a bunch of different prices.
Yep.
And then it says don't put a set excessive price.
Mm-hmm. So price will be calculated. So there is no set because you don't set the price. You calculate the price.
Yeah. So where am I supposed to put
This whole calculation. Well, think about this. When is it that you want to get the price?
Is it when I'm returning it?
Maybe it's when you are. Maybe you want to present the price in the console. Maybe at some point you set the frame size, all those different sizes there, and you say, give me the price for me to output that. So in your get, in your get, you can calculate in the get. In the get of the price, you can calculate that. What's up?
No, sorry.
Just about the
Do we have to show all the names, details, names, last name, commissions, the rate
When-
for the both
base
employees, or
salary.
only the earnings?
To do what? To demonstrate?
To display in the output.
Well, to demonstrate, okay, so let's see here. Each, to demonstrate the use of the different constructions has been created. Well, as long as you can demonstrate that you are demonstrating what is asked to demonstrate, the rest, I'll leave it up to you to make the call. I mean, if you output just part of them, that's okay, as long as you demonstrate the use of them. So again, make sure that you go through item by item. I did this. I did this one. I did this one. That's really how you knock them off.
You know, our problem is not about the input, about the output.
I get it. How to demonstrate, né?
Yes.
Yeah? Okay, so do you want to be on the safe side?
Yes.
Show everything.
Show everything.
Yeah.
Because again, there is no way to go wrong by showing everything.
No, yeah, because here you say for the second object, after you enter, the application will
Calculate
the
and display it formatted as currency.
just the earning.
Okay, yeah. So again, if you display something else, I won't say that it's wrong because you displayed something else. I mean, as long as you display that, if you're displaying more than that, that's okay. As long as you display that. Okay?
So let's vote.
It's gonna take like 3 seconds.
Is that right? So,
Well, I'm just looking at the outputs. I'm gonna, when I will be assigned grading, I'll be looking at the codes, seeing. I mean, do you have a question that you need an answer? Not is this right? No, ask me a question. Don't ask me if this is right or wrong. Ask me a question. This is not. I mean, again, if you need to understand something there in your code, in the exercise that you're not 100% sure, ask me that. But don't ask me if the code is wrong or right. I mean, okay? Check that. I can always drop by and have a look, okay? Okay, so here's the thing. The exercises, as I said, the solutions are already there under week 5. The video solutions are already there as well. So as you do your exercise, you can check the solution codes. Again, just make sure that everybody knows. All under week 5. The codes are there. The zip files for the solutions, the zip file for the solution for this other batch of exercise. The videos going step by step on how to do them, they are there as well. If you still get stuck, let me know. But anyone has any particular question that would like to ask before we keep moving forward? Anybody? Okay, so here's what we're gonna do. We're gonna have our intermission. Okay, 15 minutes. Once we get back, we're going to start on polymorphism. Then we're going to pause at 7 to do the quiz, and then we will wrap things up with abstract classes, okay? So we will be back in 15 minutes.